New discoveries on 1729, 2520, perfect numbers and Fibonacci numbers. Introduction. Welcome to our exploration of some of the most intriguing topics in number theory. Today, we'll delve into the fascinating world of perfect numbers, the unique properties of 1729 and 2520, and the timeless sequence of Fibonacci numbers. Number theory is a branch of mathematics dedicated to the study of integers and their properties. It's a field that has captivated mathematicians for centuries, revealing patterns and relationships that underpin the very fabric of mathematics. Hardy-Ramanujan number, 1729. 1729 is the smallest non-trivial taxicab number, and is known as the Hardy-Ramanujan number, after an anecdote of the British mathematician G. H. Hardy when he visited Indian mathematician Srinivasa Ramanujan in hospital. He related their conversation. "I remember once going to see him when he was ill at Putney. I had ridden in taxi cab number 1729 and remarked that the number seemed to me rather a dull one, and that I hoped it was not an unfavorable omen. 'No,' he replied, 'it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. The two different ways are, 1729 equals 1 cubed plus 12 cubed and 1729 equals 9 cubed plus 10 cubed. Ramanujan primes are a special class of prime numbers that provide a deeper understanding of prime distribution. A(n) is the smallest number such that if x greater than or equal a(n), then pi x minus pi x/2 greater than or equal n, where pi x is the number of primes less than or equal x. Few Ramanujan primes are 2, 11, 17, 29, 41, 47, 59, etc. Relation between Ramanujan number 1729 and Ramanujan primes. If we add the first 19 Ramanujan primes and subtract the 11th prime, which is 101, we get 1830 minus 101 is equal to 1729. Thus, the result is indeed the Hardy-Ramanujan number, 1729. This arithmetic highlights a fascinating connection between the Ramanujan primes and the number 1729. Additionally, there's an interesting observation: the 11th Ramanujan prime, 101, is also the 9th prime from the end when considering the first 19 primes in reverse order. And there are 10 primes before this 11th entry. This echoes the cube relationship in the Hardy-Ramanujan number 1729, 9 cubed plus 10 cubed equals 1729. This beautiful connection demonstrates how number theory can reveal deep and surprising relationships between different mathematical concepts. (2520) is the smallest number divisible by all integers from 1 to 10, i.e., it is their least common multiple. The product of 5 consecutive numbers, namely 3 by 4 by 5 times 6 by 7. A superior highly composite number. New finding on 2520. Sum of the squares of 4 consecutive even numbers 22 squared plus 24 squared plus 26 squared plus 28 squared is equal to 2520. Where 22 plus 24 plus 26 plus 28 is equal to 100. Relationship between the number 2520 and prime numbers. Sum of the first 9 odd prime numbers plus sum of the squares of the first 9 odd prime numbers equals 2520. i.e. 127 plus 2393 is equal to 2520. Both 127 and 2393 are prime numbers. 127 is the 31st prime and 2393 is the 356th prime. This method beautifully showcases how the number 2520 can be derived from the properties of prime numbers and their squares. Relationship between 2520 and Ramanujan primes. Let's take a closer look at the first 22 Ramanujan primes. If we add these 22 Ramanujan primes together, we get 2531. Now, if we subtract 11, the second Ramanujan prime, from this total, we get 2520. The number 2520 is special, because it is the smallest number that is divisible by all the consecutive numbers from 1 to 12, except 11. This property makes 2520 a highly composite number and gives it a unique place in number theory. Derive 2520 from Ramanujan number 1729. Here we have outlined the steps for two methods to calculate the number 2520 from 1729. First method utilizes the left truncation of digits of 1729 and subsequent numbers, and add all the values, we get 2496. Then take the digits sum of 2496, we get 21, and again take digits sum of 21, we get 3. We have 2496 plus 21 plus 3 is equal to 2520. Second method utilizes the right truncation of digits of 1729 and subsequent numbers, and add all the values, we get 1919. Then add pi, 1919, pi, 1729, digit sum of 1919 and digit sum of 1729. We have 1919 plus 293 plus 269 plus 20 plus 19 is equal to 2520. Relation between perfect number Ramanujan number 1729 and 2520. The sum of 2520 and 1729 equals 4249, which is equals to the sum of the first 46 prime numbers, plus 22. The difference between 2520 and 1729 equals to 791, which equals to the first 22 prime numbers. Perfect numbers. In number theory, a perfect number is a positive integer that is equal to the sum of its positive proper divisors, that is, divisors excluding the number itself. For instance, 6 has proper divisors 1, 2, and 3, and 1 plus 2 plus 3 is equal to 6, so 6 is a perfect number. The next perfect number is 28, since 1 plus 2 plus 4 plus 7 plus 14 is equal to 28. The other perfect numbers are 496 and 8128. Relation between perfect numbers 28, 496 and Ramanujan number 1729, 2520. If we divide the cube of the third perfect number 496 with the product of Ramanujan number 1729 and 2520, we get approximately 28 the second perfect number. Fibonacci numbers. The Fibonacci sequence is the series of numbers where each number is the sum of the two preceding numbers. For example, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610. Mathematically, we can describe this as xn equals xn minus 1 plus xn minus 2. New formula on Fibonacci numbers. Take 4 consecutive Fibonacci numbers fn, fn plus 1, fn plus 2, fn plus 3, we have the sum of the squares of the first and fourth Fibonacci numbers equals to twice the sum of the squares of second and third Fibonacci numbers. Application of new formula on Fibonacci numbers. In the spiral diagram, the sum of the areas of squares 55 by 55, 13 times 13 is equal to twice the sum of the areas of square 21 by 21 and 34 by 34. Can we use this method to calculate the areas and estimate the stars in our galaxy? It best suits, because it's a spiral galaxy. We can start with 3 small square areas and can derive rough estimate of stars in bigger square area. This goes on until we cover the entire galaxy and sum all those results. Thank you so much for watching our video on the new findings in number theory. We hope you enjoyed exploring the fascinating world of perfect numbers, the unique properties of 1729 and 2520, and the intriguing Fibonacci sequence. If you found this video interesting, please like, share, and subscribe for more exciting mathematical discoveries. Your support helps us continue to bring you more insightful content. See you in the next video.